be trying to put together all these things so at least I can have a module that can charge a big battery bank using the least energy from the input, and also ensure that this module can provide me power from 50 watts to 150 watts. So I'll be converting this solar panel to charge during the day and during the night. Here I have a 10 watts 18 volts solar panel. This is a small panel, of course. This cannot do so much. Might not manage to charge a huge battery. I want to demonstrate of the circuit. It's very simple to design. This is a concept in which you can use a small solar panel charging a small battery, and then that power is now harnessed to charge a bigger battery, and the module is sustainable even during the night. With my battery, I think it's usually around 92 amperes hour, we'll be charging it with this module. This module will also light this bulb. I wanted to have an incandescent bulb so at least I can show the amount of power that they can get from this. I'll be charging this thing continuously when there's sunlight or not. So my first concept is to ensure that I've connected my solar panel output wires. This diode, its basic function is to prevent power flowing back to the solar. It's a non-feedback diode. I'll ensure that I've taken some readings to see if I'm getting energy from this solar. So what I need to do is to connect my terminals. This meter, I'm purposing to use it for a current reader. For sure I'm getting 16 volts before the diode and 16 volts still after the diode. And so let me connect these terminals from the solar just to ensure that I have my battery getting charged. Right now the battery is at 10.58. Let's see if we can get the current that this battery is being charged at. Now what we need to do is just to take one of the terminals and have a series connection with the meter, and as you can see we have 0.03 amperes getting into our battery, which is good. I now want to put together this module so at least it can charge this big battery from the small battery. Also we have the inverter which we've connected already, and we have the output wires here going to this bulb. Just check again and see if our battery is getting some more voltage. It is at 10.62 now. It's getting along well. So let me communicate a little bit about this radiant charger. What happens is that I collect the collapsing field of this coil. I've sensed the position of the magnets using this Hall effect sensor, and then after I sense the position of the magnets, I switch on this coil in accordance to where it is, and so after the sensor field stops sensing the magnetism, what it does is it makes this coil stop conducting, that is becoming magnetic, and so it stops attracting. This uses an attraction mode. For the switch, I use this MOSFET, it's IRF 250, just a basic connection. And now, since I want to get the collapsing back electromotive force, I use a high-speed diode. For this case, I use the same diode, this one, which is UF5408. And since I'll have a lot of mechanical energy, I collect additional energy through using these two coils. So let me try and put back this rotor, and so the inputs to this will now come to this primary battery. Its aim is to enhance the rotation only. So this is just an LED to show whether my system is working and the situation in which it is working at. So let me start it by spinning it a little bit, and as you can see, it has started running. So I want us to see if we can measure the amount of voltage that is coming from this, the amount of energy in terms of the EMF. And since I've done the rectification here, rectification with this, of these two coils and the back EMF using this yellow line and this black cable, and as you can see, this one connects to the positive of this primary battery, and so that positive makes my negative on this, and the back EMF, if you follow it carefully, you find that it's coming from the negative, and now that's what creates our positive, our new positive, and this one goes to the output. So let's do some voltage analysis. As you can see, we have 72 volts coming from this panel, 72 volts, 72.8, 72.9. That's significant amount of energy. And let's see if we can light this LED bulb. As you can see, it's lighting, and the sound changes slightly. This is energy that is being derived from our solar panel, which is good, and this is what we want to push to this battery, this big battery. So let's continue and do the same. Making it intact again. You hear the sound changes. The whole thing is getting loaded. Now we need to see if the battery, what the battery carries, what this main battery holds. As you can see, we have 0.38. So I want to look at this other battery and see if we are draining so much from it. This one is 10.22. It's dropping slightly. This is because probably don't have enough light, sunshine. But it is still charging. And the module is charging this other big battery at full capacity. Now I want us to look at the current first. So let's look at the current that we are charging the big battery at. And so what we need to do is to remove this. Then we take the other line and connect in series. We are charging at the moment at 0.04, we have a complete setup of a very reliable solar panel that you can use at home and can replace the conventional mains. And this is a small scale. We also have the bigger modules which have bigger systems, rotary systems, and the bigger modules usually eliminate the need of this solid state inverter. So what we do in the bigger modules, power gets generated at 50 Hz because in Kenya that's what we use, and it goes directly to the utilities, the equipment, and it can generate 10 kilowatts, 20 kilowatts, 30 kilowatts. I have modules that we are making on that, and the modules are available for sale at emi.com. I'll give a link to that, or maybe once a person inquires of it, I'll give the directions and including the prices. So let me switch this on, and as you can see, we have lights, and the module keeps working, whether there is light, whether there is energy from the sun or not. Doesn't now get much concerned with the amount of light that is coming from the solar. As long as you set this thing and is up in your rooftop, then the best thing that you have to do is just wait. And when you need the energy, the energy is there. So it's a system that takes care of itself using the simple concepts as I've tried to direct to show you. And in case you really don't understand some of these things, I do coaching. Ensure that you will subscribe in my channel so at least you don't miss anything. And also put your comments there down below, so at least I can always respond and improve, or maybe you give me some requests for the ideas that you might want to experiment. I'll have enough time to experiment on your behalf.